train a proper model, so something with more epochs, so 64 epochs here, same number of units and layers, and now it starts getting very close to the test set.
What's the last parameter, regression coefficient?
Regularization coefficient.
Regularization.
So it's called L2 regularization. This is just one that I tried. I didn't do much search on it. So the mean squared error of that one was 4.43, which is about 2 and something points different from what the reviewer said, which I think is not too bad given that we have a range. So they go from, how much is that? From 80 to 96, and we are within a 2-point range. That's not bad. Then we decided to start experimenting a bit. So we said, okay, let's make the wide part very narrow and the deep part very wide, just to see what happens. So we decreased the vocabulary size in half. So now the wide part is a lot more narrow, and we doubled the embedding size. So now the embeddings, which are supposed to be very self-contained, are actually a lot bigger. And what we found is that there was not that much difference in performance. So the third model was about 5 MSE with the same number of epochs and all other parameters same as model 2. So yeah, about 5 is 2.2 points difference, 2.2, yeah, 2.23 points difference. So again, it's not too different, which sort of calls for the question, is it actually working as one side memorizing and another side generalizing? Should we make the wide part even narrower to test this? I don't know, but it's actually an interesting experiment to make. And that one is the same as that one, but with less epochs, just like sort of an early starting part. Cool. So that was our take on the wide and deep model, and it seems to work just fine. I would not claim that it is a silver bullet, but it does seem to give interesting accuracy. If someone plays with this data set with different models and so on, and wants to compare against wide and deep, just bring it over to Paper Club, and we'll be more than happy to compare. Cool. Are there any questions? Yes.
Is there like any data augmentation that you can do on this?
Yes. One of the important things that you can do is do something like this. So their input to their deep model is not actually very narrow. Like they have something like 2,000 features. They say it somewhere around here. So each embedding is of the size between 10 and 100, and well, somewhere in there it's how many features there were as input. But yes, you can augment the deep part by putting more things in it. So going back to our wine example, you can generate embeddings of nearly everything. You can generate embeddings of the country, of the designation. If you start putting some sort of meta-analysis into it, you can think, well, maybe you want to personalize your recommendation system. So maybe you think that you are closer to one wine taster than the other, so you put the wine taster name, you put an embedding in the wine taster name, and then it is also going to discern between, well, this one usually recommends good wines that are in these characteristics and so on. So yeah, you have plenty of things here that you can add, both categorical and continuous variables. So yeah.
Just a question, something I didn't get on your experiment with this wine tasting. What was it you were trying to measure? You were trying to predict the rating or
the points, yes.
Is it the per tester or in general?
No, in general. So we only keep these two columns.
Because is it a recommendation model really as such, or is it a bit different?
Yeah, well, it's it is the same setting as a recommendation model. If you had another input feature, which is the user or some sort of demographics, then it becomes a more personalized recommendation system, right? This one is a bit general. It's just based on the description. So assume that you gave these points to the wines based on these descriptions. So this would be a recommender system for someone who gives these points to these wines.
Yeah, because in the recommendation system you have to match essentially to the users and the products basically.
Yep.
And I didn't understand how you are doing this in this case. Would you just have a request?
Yeah, it's true. It's true.
Just to understand.
Yeah, I guess that the assumption for this problem is that you are the person rating all the wines. So it's a recommender system for you. Yes, if you want to, so what you said, including more features, makes it actually more of a recommendation system, because then you can input, oh, I like wines that come from this country and from there and from there and from there, and then it can recommend a wine for you, for
Or
example.
if you put the testers as clients, for instance, then you can predict would they like this one or that one.
Yeah, also. So,
and also, it's a minor point within the data generation. They say that when they have continuous features, and I get the impression that they discretize it by quantiles.
yes.
Do you know why they do that? Why could they keep them continuous?
Why don't they keep them continuous? I think that the quantiles part was to normalize them, and then.
Maybe I misunderstood, but I thought that they not only put them between 0 and 1, but also then, if you are between, say, 2/3 and 3/3, you will be 3, as opposed to. And I wasn't sure why they would make it discrete. If there was a reason, or if I maybe misunderstood. No, it's 4.1 the data generation.
No, it's normalized by quantiles. So you calculate the quantiles of your distribution, and then you normalize based on which quantile it falls in. I think that's what they said.
Okay, well I'll have to look it again. Okay.
Right, so IQ quantiles. Normalized value is for values in the IQ quantiles. So yes, you bin them by quantiles and then normalize the value. So I'm not sure. Again, I'm not sure, but what it seems to me that they are doing is that they are. So each quantile becomes a feature, and it's normalized inside that quantile.
Okay. Okay,
Maybe, but again.
In your case, it's irrelevant because you didn't have any continuous.
Well, yeah, we did not have any continuous variables, but what I would do is normalize the continuous variable and then make it as an input.
Yeah,
just normalize.
But without using the quantile.
No.
Yeah.
It's also. I mean,
unless you see a reason for doing this, but I didn't.
Yeah, as with every application, the data transformation has to be specific to your application. So maybe these continuous variables have specific distribution or a specific thing, or maybe the range is just too long, and you don't want to squeeze it all between 0 and 1. So you divide it in quantiles and then normalize that between 0 and 1. Yes?
Yeah, I don't know if they mentioned in the paper. So when you have Google App sort of recommendation engine, does that mean every new app that added to the system, your input feature have to increase exponentially because you have to pair them up